This video is on oxymercuration-reduction reactions. Hydration is not an effective way to add water to a double bond. An effective alternative is oxymercuration-reduction. This reaction has two steps: the oxymercuration step, where you're adding a mercury and an oxygen across the double bond, and the reduction step, where you replace the mercury with a hydride. In this example here, we are using mercury acetate and water for the oxymercuration step and sodium borohydride and sodium hydroxide in our reduction step. These are not the only conditions you could have. You could have practically any mercury ion source and water followed by any reducing agent in the second step, but I recommend you learn these ones as they definitely work. The mechanism is as follows. The mercury acetate breaks down by losing the acetate anion to give you a mercury cation. The mercury cation acts as an electrophile, so the alkene reacts with the electrophile, forming a carbocation. The spare electrons on mercury will then form this bromonium ion equivalent, but with mercury, which is then attacked by water. The water will be deprotonated by the loose acetate anion to give you your oxymercuration product. This can then be reduced with a hydride, so a hydride will just replace the mercury to yield our alcohol. Oxymercuration follows the Markovnikov rule, so we would expect the oxygen to attach to the more substituted carbon, which upon reduction give you the more substituted alcohols. Now you have a go. What would be the products of these two reactions? You may pause now. And here are the answers. If an oxymercuration reduction is done upon an alkyne, you will form a ketone instead of an alcohol. This is not due to the conditions of the reaction, but in fact from formation of an enol, which is an alcohol on a double bond. Enols cannot be isolated because they spontaneously rearrange to become ketones. It is said that enols and ketones are tautomers. This spontaneous conversion between enols and ketones is called a keto-enol tautomerization. An example here would be an acetone tautomerizing to its equivalent enol. For all intents and purposes, it resembles a resonance structure, but in this case, we are actually changing between two different constitutional isomers. Keep an eye out for this tautomerization, as it will make it an appearance a lot more from now on. Just remember that you cannot have an alcohol on a double bond. It will become a ketone. You may also have noticed that the conditions are different for this oxymercuration reduction, and this is just another example of conditions that can be used. The mercury cation that is shown without anything could be any of these following mercury compounds, as it is not about what is attached to the mercury, but the actual ionic state of the mercury. On the plus side, if the conditions aren't a two-step process, you're not expected to know the mechanism, although assume that it's something very similar to what you have seen prior. Long story short, if you see a double or triple bond and you see mercury in your reaction conditions, expect to form some form of alcohol, and in the case of a triple bond, it will be a ketone. Now you have a go. What would be the products of these following reactions? You may pause now. And here are the answers. Oxymercuration reduction is a very effective way of making alcohols from double bonds and ketones from triple bonds. However, the issue with mercury is that it's super toxic. And when it comes to toxic chemicals, we tend to try to avoid them. Now, there are multiple different alternatives for oxymercuration reduction, but most of them have mechanisms that you do not need to be even familiar with. They are too advanced. However, one that you should learn so that in the future when you're in grad school and you get asked how to make an alcohol from a double bond, you can show off, is the Mukayama hydration. You need an alkene, some oxygen, cobalt acac, and phenolsilane. If you mix this, which is brewed together, you will form a alcohol that follows the Markovnikov rule, i.e. the same product as you would get if you used Oxymercuration-Reduction conditions, but you are not using mercury. You need to know the name and the conditions, and that is all. So for example, what would be the product of this reaction? Just know that we're going to be forming a alcohol following Markovnikov rule, and that is all. Now you have a go. What would be the product of this reaction under the Mukayama hydration conditions? You may pause now. And here is the answer. Note that it follows the Markovnikov rule.